Greetings. As some of you may recall, I recently did a three-part video series on the restoration of this Gibson GA-35 Lancer amp, and I really thought it turned out great. Just recently I started doing comparison videos where I play like 9 or 10 different vintage amps, one after the other, to compare the tone. When I played the Gibson in comparison to the others, the tone was so atrocious that I was really shocked. Now what I'm going to do is play the recorded session that I heard with the amp in this condition, and then I'm going to take it out in the workshop and do my best to fix that situation and see if I can give it a much better tone. If so, I'll bring it back in and we'll record a comparison passage. So let's see how it goes. Okay, we're leaving the first half of the 12AX7 of V1. We're going to go through the bass control, treble control, volume control, and then we're going to go through some very strange little voltage dividing network here with capacitors that feed into the grid of the next stage of amplification. Then we do it again here. Now, if this was the best sounding amp in the world, I'd say, gee, these are weird, and I've never seen this on any other amp. That must be why it's so wonderful. But instead, this sounds terrible. It's like fingernails on the blackboard. So since this is unusual, I'm going to remove both of these and replace them with a 0.02 microfarad capacitor, just like most amps have. And let's see how that sounds. Okay, I removed that voltage divider and capacitor network that I showed you on the schematic. It's been separated from the volume control and from the 12AX7 tube. But I have used jumpers to reconnect it so that we can hear what it sounds like with it, and then we will hear what it sounds like with just a straight capacitor running from the volume control to the next tube. Just ridiculously shrill and metallic. Okay, now let's see what it sounds like with just the capacitor. Okay, now here we are with just a 0.01 microfarad capacitor. Still rather bright. Let's try a 0.02. Okay, here's a 0.02 microfarad capacitor. Alright, but let's remember there's one more of those voltage divider networks in this circuit. So let's leave this with the 0.02 and then bypass the next one. Okay, now here I have both of those voltage dividers bypassed with 0.01 microfarad capacitors. Sounds pretty good to me. Okay, let's have a quick review then of what's been done. You see all the components that were removed. Okay, we're going to go from the wiper of the volume control, and this is on the normal channel, and you remove the two 220K resistors, the 330 picofarad capacitor, and the 0.0047 capacitor to ground. Remove those. Then you replace all of that with a 0.01 microfarad capacitor, which will be from this wiper to the grid of the tube, and then on the grid side of the capacitor run a 1 meg resistor to ground. Now the other one, remove the same parts, okay, but there was a 0.01 microfarad capacitor coming in here, and there is a 220K resistor. So I left those two in place and simply removed the two 220s, the 330 picofarad and the 0.0047, and then just ran a jumper wire from this junction into the grid of the tube. Okay, now let's listen to it and see what you think. It should be noted that the two networks I removed are from the normal channel. If you also want to improve the tone of the tremolo and reverb channel, you'll need to remove this third network. Okay, just take it out exactly like I did this one just above it and replace it with a 0.01 microfarad capacitor. Well, that about does it for today's video, in which I believe, dramatically improved the sound quality of the Gibson GA-35 Lancer amp. The modifications that I made will apply to most of the Gibson amps from the 1960s. Check your schematic and see if you don't have that voltage dividing network in there. I have no idea what the purpose of it was, but it sure works better without it. Okay, so I hope this was informative and helpful to some of you. I hope you consider subscribing to my channel, but most of all, I hope to see you again soon in the near future. Thanks for watching.